Słuchajcie, witam Was serdecznie na naszym 12. spotkaniu. Już. Czas leci szybko. Dzisiaj mamy dwóch prelegentów, Sebastiana i Tomasza. Chciałem zacząć tutaj takim wstępem o tym, że w zasadzie chcemy się trochę przekształcić ze Scala Uses Group w coś, co chcemy nazwać Functional 3CP. I chcemy też tutaj pod nasze, że tak powiem, skrzydła przyjąć też jakichś takich uchodźców w stylu Clojure, Erlang, Haskell, czy jakiekolwiek inne funkcyjne, nawet i techniki, na przykład w JavaScriptie można funkcyjnie kodować, w Javie nawet, także taki mamy pomysł na nasze spotkania. No i mam nadzieję, że to też rozszerzy grono zainteresowanych, bo tu już powoli widzę takich stałych wywalców, co zresztą jest fajne. No ale też chcielibyśmy tutaj nowych ludzi zaprosić, no i promować programowanie funkcyjne per se. Także myślę, że możemy nawet chyba jakąś ankietę na meetupie, nie? Zrobić, Monika, i zapytać nasze grono tutaj, co o tym myśli.
My tak od nas właśnie, bo kilka ankiet już starałyśmy się wdrożyć, także jakbyście byli tak otwarci, żeby na nie podpowiadać nam trochę i też włączyć się w ogóle w organizację spotkań w ramach prezentacji, bo też bardzo chętnie, no każdy, kto będzie chciał zaprezentować jakiś fajny temat, to jest mile widziany. Także...
Tak, cały czas tutaj, jeżeli macie coś, jakieś nawet podstawy czegoś, albo nie wiem, jakiś temat, który ktoś chciałby zeksplorować, to jest też dobra metoda, żeby czegoś się nauczyć. Tutaj nie musi to być coś super zaawansowanego, tym bardziej, że no, chcemy tutaj na różnych poziomach dla ludzi, zarówno początkujących, jak i zaawansowanych, żeby tak po trosze zadowolić wszystkich. Jeżeli ktoś chciałby coś zaprezentować, to jak najbardziej tam na meetupie można się odezwać, zgłosić. Także dobra, ja już więcej czasu nie zabieram, także dzięki. No i Sebastian opowie o mikroserwisach.
Z Akką po angielsku, bo jest łatwiej chyba. Okay, my name is Sebastian. I'm working at Scala C as Scala developer, and I would like to talk today about building reactive microservices with Akka. This will be an architectural presentation, so you may be a little bit disappointed that you will see no code today, maybe in the future. And I would like to start with a short introduction to domain-driven design. First, what's actually a domain? A domain is our business. When we are in Ecommerce, our domain is selling stuff. When we are in logistics, our business, our domain is transportation and shipping of goods. And when we are a bank, actually I don't know what they are doing. And in a domain, we have entities. What are the entities? Entities are our main concerns in this domain. Like when we are, for example, in an e-commerce domain, then the first thing it comes to my mind is an order, yeah? And the most important thing about entities, they have a unique identifier. So we can distinguish two entities. We can, they have an ID, yeah, like in the database. And we are interested in a sequence of valid changes over the lifetime of this entity. So when we are again talking about the order, it's registered, confirmed, paid, and then shipped. And so we are looking for a thread of continuity. And we are able to track events in the life cycle of this entity. So the important part about entities is that you don't compare entities by their attributes. So you can have two completely identical orders, and yet they may be two different orders. So you can compare entities only by their unique identity. So there's another thing here. You can also have different representation of one entity, and yet you are talking about the same entity when they have the same identity or the same identifier. Next thing here in our domain-driven design is are values. Values are the actual attributes of our entities, and they measure, quantifies, and describes our things in a domain. The most characteristic thing about values, they are immutable, and they can only be replaced as a wall. So when we have, for example, a user and the user has a contact address, we never change this street or postal code inside the address value object, but we are replacing the wall value. And the values have no identifier, so they are compared by the attributes. So when you have two values and they have the same attributes, they are equal. And of course, if they have methods, these methods or functions are side effect free. So this means then when we have a function that produces some change, we will get a new value, and the old value is unchanged. Okay, here is a picture to visualize the difference between values and entities, because it's sometimes not clear from a description. So when you are in the e-commerce business, you have orders, and an order has a total of 200 PLN. On the other hand, when you are a central bank and we are printing money, you are interested in every single bill. You are interested in the serial number and the series and the number of the bill. On the other hand, when you are in your shop, you don't care if you get 200 bill with this serial number or with another. They are equal. 200 is equal to 100. Even when you get a wire transfer, then you will not see a 200 bill anyway. Okay, next thing here is aggregate. Aggregate is actually a graph of entities and values, and we are trying to achieve and maintain an invariant that is always true, so that we can't change, for example, two entities with two different threads at the same time and violate this invariant. Like, for example, you would have an order and you would have items, and you would change with one thread the quantity of the first item, and with another thread the quantity of the second item, and then you would get out of sync. So natural fit for these aggregates are actors, because we have a sequencing of messages, and the changes are applied sequentially. Okay, so the important part to understand in aggregate that we always have a root entity, and the root entity must have a global identity. All other entities inside the aggregate graph may have a local identifier, like a shortened GUID or something like this. because these entities are not accessible from the outside of the aggregate, only as values perhaps. So when we are looking up or when we are sending messages to aggregates, we are always sending the message to the root entity. What did I say? Quantities. Okay. So next thing in our domain-driven design is application service. Application service is a stateless service and is acting as a facade to our domain model. And the role of an application service is actually to make it possible that, they are actually task managers, transforming use case flows, requests into execution of domain logic. So they are mediating between an outside world and our domain. So many times they are generally providing security and transaction management. And when more than one entity is involved, they can, I can't remember the word, they can match that they play well together. Okay. Okay, bounded context. Bounded context is another concept of our domain. Many times we have a business that falls apart into subdomains. Like in the Ecommerce example, we don't have only orders. We also have shipping, payment, and many other things. And a monolithic application would try to solve the problem with one model. But with the bounded context, we are concentrating on one aspect of our domain. For example, selling or shipping or payment. And a bounded context is the formal name of such a boundary around a subdomain. So we have, what is the consequence of this? We have for every specific subdomain an own domain model. And this is actually this corresponds actually to microservices. So that's why I'm talking here about domain-driven design, because actors are a great fit for aggregates, and microservices are a great fit for bounded context, or other way around. So one thing to mention is a system or a methodology called CQRS, event sourcing. It's command query responsibilities aggregation, and it's about splitting up the command model and the query data model. So there are two different use cases. One thing is we want some transactional behavior. We want to change some internal state of our application. And the other use case is we are just searching. We are querying our data. And in a situation where we have a lot of data, it sometimes makes no sense to join data in a database with big joins. So we can denormalize our data into a flat view structure. So we have a command model, and this command data model is producing events when it changes. These events are added to a data store, an event store, like Kafka, for example. And then a consumer is reading these events one by one and doing some projections on these events. So normally where we would have perhaps 2 or 3 tables, these projections are producing data into one table, a flat data rows. And then we can query this data model much more easily. Okay. Next thing is microservices. Okay, this is what is microservices actually? Yeah. Yeah, it's so obvious. Yeah, microservices. No, everybody knows what microservices is, but what is formally? Yeah, it's a single application, a suite of small services, and each small service is running in his own process, and the microservices are communicating with each other over a lightweight mechanism like HTTP and JSON, REST endpoints, or message queues. And the microservices are trying to keep their domain very small. They are built around business capabilities. And therefore, they are actually bounded contexts in that way. And one thing to note is that they are most of the time independently deployable by fully automated deployment machinery. So every team, so you can split up your big application into small microservices, and each team can work on one microservice called product and deploy it independently of the other teams. So there is another benefit. Okay, here's an example of such a Ecommerce microservices. This is not probably this is not complete, but to get a feel how this may look like, we have a catalog, bundle context, items, ratings, business intelligence, security, discount, cart microservice, sales, payment, inventory, invoice, and all of them are also microservices and bounded context. So each of these microservices can be implemented as a hexagonal architecture. This means we have in the core our domain model, and this is accessible only through application services or event listeners. And the domain model is only using, or yeah, actually the event producers. No, one moment. Domain model is accessing event producers and repositories. So in even further outside rings, we have our API adapters. Okay, maybe I should explain. This is the input side, and this is the output side. So on this side, we have our REST endpoints and our Kafka consumers. And on this side, we have our, for example, Kafka producers and our database access objects. So when we take a look at perhaps some REST endpoint, we have API, REST API. It gets deserialized or demercialed, and then an application service is called with the message, and the application service is calling some domain object or an aggregate. Or on the other hand, some event can come in and gets processed here by the event listener and forwarded to the domain model. On the other hand, we have the domain is producing events. Inside a transaction, when data changes, the domain model may create events. And these events are queued by adapters to the message queue. And we have repositories. This is for database access. And you are using database drivers. This is persistence adapters. OK, let's go to the core of this presentation. Reactive messaging patterns with Akka. First, messaging pattern is quite obvious. When you are using Akka, we have a chain of actors, and there's incoming message. And the message is passed along the way and gets augmented. So this is pipe and filters. For example, an incoming message can go through authentication, which can call perhaps a security boundary context and which uses Redis. And then when the authentication filter passes, then it goes further to the authorization, where perhaps the user roles and the message type is checked. Then it can maybe go to deduplication, perhaps the message comes twice. And the interesting part about this is actors don't need to know about each other. So we can put other actors between. Or we can remove, for example, authorization. Next pattern is the service activator. This is a typical situation where you have a REST endpoint and someone from outside your domain or microservice is calling your service. You need to activate your service by some kind of endpoint. And in our case, you can use, for example, play and provide some endpoints, REST endpoints, and this and receive some JSON. Deserialize this to some messages and call then the application service. And on the other hand, you could also have other service activators like the message queue I talked before. And then the application service is calling the domain model. Normally, you would have this here in Akka, the application service and the domain model, and the service activator you have in play, because it's quite straightforward to implement this. Next messaging pattern is the process manager. This pattern is more complicated or more complex. The process manager is coordinating a bigger transaction. The command message comes in, and then it creates a process entity where it will store the actual state of the transaction. Then it will call perhaps one or two external services, and when they are providing the answers back, the process manager is forwarding the messages to the process entity, where the process entity says, yeah, all data that had to be changed or processed has sent a reply. Then the process entity sends a finished or success message to the process manager. Or there can be also a timeout, then the transaction fails. Good. Next pattern is durable subscriber, especially here in this case a projection. As you have seen in the CQRS environment, you need to take the events and perform a projection into a database, for example. And you can achieve this with a durable subscriber. On the other one hand, you can have a persistent actor that, when the data changes, publishes or emits events to a Kafka's event stream. And then you can have a persistent query which will read these events and project them into a database. So the persistent query would be the durable subscriber, because the persistent actor is the producer and the persistent query is subscriber. Another use case for the durable subscriber is integration of different microservices. So you can have, for example, again, the Ecommerce sales example. You can have, for example, the payment bound context and delivery bound context emit events like an order is getting paid or an order has been shipped, and then the sales bounded context or microservice can listen to these events and change its internal state accordingly. Okay, and when we put all this together, all these messaging patterns I've shown you before, then we will get anatomy of the CQRS event source microservice. You have the service activator with the REST endpoints. When a command comes in, it goes through the pipes and filters, the security authorization thing. Then it goes to the process manager, which will call perhaps other bounded contexts or microservices, and then send some messages to our aggregate persistent actors, which will emit then some events to an event store, or here Kafka event log. And then these events will be consumed by, on the one side by projections, which will by a persistent query which will do a projection into a database. And on the other hand, we could have some integration where some other bounded context or microservice will consume the events and change their data accordingly by calling an application service or here process manager. And we will have also this query endpoints where we can perhaps by Slick fetch some data from the database. And this is actually all I have. Okay, here's further reading. These are books about domain-driven design and implementing domain-driven design. And reactive messaging patterns, there are much more reactive messaging patterns with the actor model. And this is to be continued with some code examples. I've started to implement some of them, but especially I wanted to prepare an example with Ecommerce, but yeah, there are a lot of moving parts, perhaps next TSUG. So, any questions? I don't know how many.
Maybe a generic one. So, what are the advantages of microservices architecture?
The main advantage is the concentration of a very small subdomain of our big application. We're talking here about large application, not a small shop, but yeah, enterprise systems, where you have, like Amazon, for example, where you have a lot of data, and you need to be able to move quick and change your domain and domain logic and your functionality very quick. So you have these microservices where you have very small area you are concentrating on, and your team can deploy your microservices independently and actually a few times a day even.
I have a question about this hexagonal architecture.
Okay.
Because I've noted that there were only 4 sides used of this hexagon, so
yeah.
It's called hexagonal.
Yeah, actually, let me move back. Okay, here. Actually, these things I've put here inside I've cheated a little bit because this is not actually these are not static parts of the hexagonal architecture. Normally, each side is an adapter access point, and you could have here HTTP, and on the other hand, you can have here TCP or other protocols. and it's not only queue adapters or API adapters or REST endpoints. There are all kinds of endpoints possible, like Comet or WebSockets or I don't know, all the protocols. On the other hand, you can call also many different systems, not only databases and message queues, but you could also produce emails, and you could, I don't know, upload files or something like this. Or you can just call outside of your microservice to another microservice. So you will still need, it's called a domain service that actually creates a JSON request and calls an external service and processes the response and gets the result back to the domain model. So another name for the hexagonal architecture is ports and adapters. So outside the yellow ring are the adapters. Here are the ports, and here's the domain model. Okay. So, okay. Yeah. Okay, thank you.